Your power amp is rated 100 watts RMS, or any other number of watts. In this video, I'm going to show you why this doesn't make sense, and exactly how your amp should be specified. And if you don't know already, I'm going to tell you what power actually is. And we'll be hearing from Audio Phil at the end. Don't forget to like and subscribe, and get involved in the comments. If you have a question, ask it in the comments and I'll consider it for a future video. It should be so easy to measure the output power of an amplifier. Connect a load, a dummy load or a loudspeaker, and see how much heat comes out. But it's more complicated than that. In fact, it's more complicated than I'm going to cover in this video. But I'm going to raise an interesting point. By the way, if you already understand the use of the word average in this context, you may click away now. Funny cat videos will be a better use of your time. Or you can watch further and offer any useful insights you may have in the comments. So, experts, watch to the end, save the cats for later. What we want to know most about a power amplifier, whether we are audio professionals, audiophiles, or mere hi-fi enthusiasts, is its power output, its real power output. If you look at power amplifiers in a handy place where there's a whole bunch of them, Amazon, you will see amazingly powerful amplifiers that are amazingly compact at amazingly low prices. But if you look further, you will find that the headline power output often corresponds only to a very particular set of circumstances, and real-world users will get less, sometimes a lot less. And then there is the method of measurement, which, as I said, is complicated, and I'm covering just the most simple aspects here. So, to quote from the laws of physics, as handed down to us by the oracles all the way from Thales to Wikipedia, power is the rate of energy transfer. So your main socket has energy available, and your power amplifier transfers it to your speakers, where most of it is wasted as heat, but that's another story entirely. We can calculate power from voltage squared divided by resistance. Yes, I know that a loudspeaker is not a purely resistive load, but I don't want my head to hurt, and I suspect neither do you. But how do we measure the voltage? Let's take a sine wave. Here's one. You can see that it has a peak and a trough. Or you could call them the positive peak and negative peak, which I prefer. So we could measure the voltage between the positive peak and the negative peak, square it, then divide by the resistance of the load. It will give us an impressive figure. Say the peak-to-peak voltage is 34.64, a nice round number. Square that and we get 1,200, which is a nice round number. Divide by 8 ohms, which is typical of a loudspeaker, and we get 150. 150 watts. These, I have to tell you, are not watts for the real world. The problem is that measuring peak to peak doesn't give us a proper appreciation of the oomph of the waveform. Oomph is not a technical term, at least not yet, but I can show you why it's useful. As we can see, the negative part of the waveform is symmetrical to the positive. So, intuitively, we can say it has the same oomph. So we could conceptually flip the negative half so it fills in the gaps between the positive peaks. If we measure this now, it's half what it was before, 17.32. So square that to 300 and divide it by 8 and we get 37.5 watts. A quarter of what we had before. This is the peak measurement. And again, I have to tell you, these are not watts for the real world. Look at this. It's a square wave. While the signal is at its peak, the full voltage of the peak drives current through the load all the way from start to finish of that positive half cycle. Likewise for the negative peak. But the sine wave has gaps. Which, do you think, assuming the amp has current available, is going to produce the most power? Real-world heat. Clearly, the square wave. So the sine wave is producing less real-world power. How much less? √2 less, according to the maths. Divide the peak measurement by 1.414 and we get the root mean square, or RMS measurement. This represents the true oomph of the voltage waveform. Anyone with an interest in audio, when they first learn this, loves it. It's a solid connection with the real world of human experience. It doesn't flatter the amp specifications, it doesn't raise false hopes. It tells it as it is. Our peak-to-peak voltage of 34.64 translates to a peak of 17.32 and an RMS voltage of 12.25. Square that to 150, divide by 8, and we get 18 3/4. 18 3/4 watts. Real oomph watts. Heating power. A lot less than the 150 fake watts we started with. Now, I'm going to tell you why your amp is average. We have voltage RMS, or RMS voltage. This is true, real, correct and useful. 18 3/4 are the quantity of watts this will produce through an 8 ohm load. So we have 18 3/4 watts RMS. Oops, we don't. Watts RMS is a phrase that reverberates through the world of audio, professional and domestic. A Google search for this exact phrase in quotes gives nearly 6 million results. The thing is, though, that it's wrong. Not just technically wrong, actually wrong. Let's use some simpler figures, still using a sine wave, and a little rounding in the decimal places. Peak to peak is 2.828 volts. Peak is therefore 1.414 volts. There's that square root of 2 again, which is just a coincidence. And RMS is 1 volt. 1, the roundest of round numbers, apart from 0. Let's use 1 ohm as the load. So power is 1 squared divided by 1, which is 1 watt. The voltage was RMS, but is the power RMS? I'll tell you now, it isn't. Where the voltage swings between plus 1.414 volts and minus 1.414 volts, the power swings between 0 watts and 2 watts. So this gives an offset of 1 watt. So to calculate root mean square, we have to take peak to peak watts, divide by 2, divide by root 2, then square all that, then add the offset squared, then take the square root of the whole lot. Yes, I know it's complicated, and there's a link in the description to a fuller explanation. The thing is, though, that this RMS calculation gives us the result of 1.225. And I can genuinely say 1.225 watts RMS. Unfortunately, this doesn't relate to anything meaningful. Sitting on our sofa in our listening room to our monstrously expensive loudspeakers, we don't hear watts RMS. What we do hear is the average power. Yes, average. Just plain average. Not some mathematically convoluted interpretation of the word. The average power here is 1 watt, because the waveform goes up to 2 watts, down to 0 watts, and is symmetrical, centred on 1 watt. 1 watt average power. Betty will quote from our reference, linked in the description.
The average value of this power waveform is 1 watt. This is obvious from inspection. The waveform swings symmetrically above and below 1 watt. The same value results from calculating the numerical average of the waveform data points.
So, if you thought that your amp had a specification of X watts RMS, it doesn't. Or at least, it probably doesn't. And if it does, that figure is either not RMS, or it is RMS and it's meaningless. It probably has an output of X watts average power. X watts average power. I mentioned at the beginning that experts should watch to the end. So, assembled experts, it isn't inconceivable that I've made a mistake, or explained something with less clarity than I could have. This is why we have a comments section, and I suggest non-expert viewers should check there for updates. You know, I'm going to miss watts RMS. If I Google watts average power, I get more results for cycling than I do for audio. What with an H, do you think? Should we be correct and talk about average power, which hardly anyone other than experts understands? Or should we use watts RMS as a shorthand, even though we know that it's wrong? It isn't up to me. Don't forget to like and subscribe and get involved in the comments. If you have a question, ask it in the comments and I'll consider it for a future video. See you soon.
Hi, I'm Phil, Audio Phil. Average power doesn't account for the lightning-fast transient response of my system, which reproduces the initial attack of instruments with incredible accuracy and resolution. My components are hand-picked, each chosen for its exceptional quality and ability to elevate the music, far exceeding the capabilities of mere average power.